Welcome back, my dear friends and students. A very good morning, good afternoon, good evening to all of you who are taking this course titled Multi-Criteria Decision Making under MOOC NPTEL. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur in India. And the broad outline for few sets of lectures which we have been continuing is in the area of definitions of MCDM concepts, utility theory, safety first principle and stochastic dominance, and today we will start the 12th lecture for this total series of 60 lectures, which is spread over 12 weeks. Each week we have 5 lectures, half an hour each. What will be the coverage for this lecture? Even though many points are written, we will cover it as you know that as you proceed. Nothing is left, only that the overall broad line is given and we slowly proceed. We will consider the properties of a utility function, concept of risk aversion, risk neutrality, risk seeking properties. What is the concept of marginal utility? What is the concept of absolute risk aversion, relative risk aversion? We will consider that. There are two different topics. We will consider examples of utility theories and so on and so forth we will be covering. So, obviously, this slide which you are seeing we will cover later on, but this is just given as a precursor. So, considering the property where we left the 11th lecture, which was the first lecture in the third week. So, we did discuss the concept of first the concept of non-cessation, property 1, property 2 was basically property related to a person being risk loving, person being risk indifferent, person being risk hater. And we did discuss in details with a fair gamble with the outcomes increasing for the output as well as for the sure event, and their person can decide whether he or she will go for the gamble or go for the certainty event. And as we have seen, as the question was asked, that as the stakes increases, people do change their decision from being a person who is willing to take the risk to a case where he is indifferent, she is indifferent, and then being a person who is avoiding the risk. So, considering those three properties, risk loving, risk indifferent, risk hater, we will consider these three things. Number 1 is basically the person who is risk averse. Number 2 being the person who is risk neutral, and the number 3 is basically the person who is risk seeking. And based on the second derivative, because the first derivative give you the concept of non-cessation. First derivative means the derivative of the utility function. So, considering the second derivative is less than 0. So, you have I will use different colors in order to make a note of that. So, it is the second derivative being less than 0 gives you the risk aversion property. The second derivative being equal to 0 gives you the risk neutral property, and the second derivative being greater than 0 gives you the risk seeking property, and we will see that diagrammatically also. So, these are basically this is the second derivative for the third case greater than 0. This is the second derivative, I am just repeating it, please bear with me. Second derivative for the second case is risk neutral, and this being the second derivative for the first case, which is risk averse. So, if we draw the diagram and we should note down what is there in the x axis. X axis is the wealth here and y axis is the utility. So, if you have this, the property related to where obviously very interestingly in all these three diagrams, the green one, the blue one and the red one, the property of non-cessation, which is more I give you more you want, which is the first derivative being greater than 0 always holds for all these three. All these three means for the red one, yes, I am putting the colored tick mark accordingly. For the blue one, yes, and for the green one, yes. Now, coming back to the concept of double derivative, which will denote whether the person wants to take risk, is indifferent or is avoiding the risk. So, obviously, if I see the second derivative, for the red one, the second derivative which is increasing at an increasing rate, all three are increasing, but the red one is increasing at an increasing rate, which means the red one would be the case where it is greater than 0. So, he is a person who wants to take risk, is basically a risk lover. A risk seeking person. So, this is for the red one. If I see the blue one, second derivative is increasing at a constant rate. So, it is 0. So, it is basically a risk neutral. So, I will not write the word risk. So, but I will only write the concept of neutral person. And for the green case, the it increasing at a decreasing rate less than 0. So, is basically the person who hates risk. I am not using the word risk, is risk hater, risk neutral blue one, and risk lover. So, using the diagrammatic representation of the utility functions, you can classify the human being as loving risk, hating risk, and being risk neutral. The color schemes are giving accordingly. So, the green one is basically for this, the blue one is for this one, and the red one is basically for this one. So, marginal rate is basically the rate of increase. So, if I consider the marginal utility functions based on the fact what we just discussed in the last slide of the diagram, here you will have the marginal rate is basically marginal utility function looks like a concave function which is a risk averse person, which means that it is increasing at a decreasing rate. For the case where the marginal utility function looks neither concave nor convex, which is risk neutral person, which is wants to take risk or avoid risk, both are same. And for the person where the utility function looks convex, he or she is a risk taker because it is increasing at an increasing rate. So, here u double prime greater than 0 for the third bullet point. For the second bullet point, u double prime is equal to 0, and the first bullet point is u double prime is less than 0. Then, if I consider the marginal utility rates, which I have discussed, there it becomes more detailed explanation. What have I been talking about verbally? So, for the case where you have it is increasing at a decreasing rate, is a risk averse person, which is this. This is marginal rate. It is increasing at a constant rate, which is risk neutral person, which is double derivative is equal to 0. And if it is increasing at an increasing rate, is a risk seeker, where the double derivative is greater than 0. So, the diagrams basically portray it. So, if I draw it accordingly here, this is same thing. So, the red one would be increasing, the blue one is constant, and the green one is decreasing here. So, the risk averse person, the increase is happening, but happening at a decreasing rate. So, if I draw the tangent, so for this point A and for this point B, so the line, if the line moves like this, so from my side if I am looking, moves like this, and slowly it decreases. So, the rate of change, if I have drawn the angle, so this if I draw A here, A point is here and B point is say for example here. So, if I draw this is angle theta A, this is angle theta B. So, obviously, theta A is more than theta B and so on and so forth. So, it slowly becomes horizontal. So, this is a risk averse person, and obviously, this should be true, and which I am pointing out, sorry for my repetition. You draw the utility functions along the y axis and the wealth along the x axis. If I consider the risk neutral person, so it is increasing at a constant rate. Again, the wealths are denoted along the x axis, utility along the y axis. So, here you will basically have u double prime being 0, because constant, u prime is constant. If I go for the third diagram, which is risk seeking person. So, here if I consider again point A, point B. So, if I am able to draw it, this is A and consider this is B. So, if it is theta B, is theta A is less than theta B, because it is becoming vertical. Again for convenience, we have drawn W's along the x axis and UW along the y axis. So, this is a risk seeking person. Now, continuing with the other important concepts, if I consider risk aversion, risk neutrality and risk seeking person, with based on the fact that we have considered a fair gamble, the situation along with the concept of u double prime, the table is made accordingly. So, if I consider a risk averse person, so sloping curve going down, there obviously he or she would reject the fair gamble and take the sure event. So, reject the fair gamble, take the sure event, and obviously u double prime is less than 0, because the graph which you have is sloping downwards. If I consider the risk neutral person, he or she would be indifferent to the fair gamble with respect to the sure event. There in that case u double prime is equal to 0 and the graph is a straight line. Graph consequent and then finding out the second derivative. And finally, for the case when he or she is a risk seeking person, would select the fair gamble and avoid and not take the sure event, the overall graph of u double prime would be greater than 0, which means the graph is increasing like this. Now, we will consider the third property. Third property is known as the absolute risk aversion property, which is property 3, and for the utility function, and it can be proved, we are not going to the detailed proof, that the concept of absolute risk aversion and the corresponding A prime we will also see is given by this. A prime A is basically the ratio, which again I am saying it can be proved, of the negative value of the double derivative in the numerator and the one derivative which is non-Satian property in the denominator. So, obviously, we know that u prime is always greater than 0 and this property of u double prime can be less than 0, can be greater than 0 and can be equal to 0. So, based on that you will basically have the A prime property also, which is known as the absolute risk aversion. Now, what is the concept of absolute risk aversion? Qualitatively we will come to that. So, it can be proved that for a decreasing absolute risk aversion, which is for the case when you have A prime, not A prime as which is dA by dW is less than 0. So, A prime being less than 0, it is given as the decreasing absolute risk aversion. So, the person's absolute risk aversion property is decreasing. So, mark the words, the risk aversion property is decreasing in the absolute sense. If somebody wants to consider A prime as 0, which is here, then there is a constant absolute risk aversion property. And for the third case, when A prime is greater than 0, you have the increasing absolute risk aversion property, and mark these concepts which I said: absolute risk aversion property, absolute risk aversion property, absolute risk aversion property, and they, as you see, can be in decreasing, constant and increasing. Based on that, you have A prime being less than 0, equal to 0 and greater than 0. What does it mean? This is what the slide says here. So, if I have the decreasing absolute risk aversion property, where the fact is A prime is less than 0, then it means that as wealth increases, wealth means W increases, the amount held in risky assets also increases. So, it is worth decreasing absolute risk aversion. So, the risk aversion property is decreased, that means I am willing to take the risk. So, that is why I said mark the words. So, it increases the amount, the person increases the amount in quantum terms held in risky assets. If it is constant, where A prime is equal to 0, then as wealth increases, the amount held in risky asset remains same, and if A prime is greater than 0, it means the person is increasing absolute risk aversion, and as wealth increases, the amount held in risky asset decreases. So, these were from the point of view of absolute risk aversion property. So, mark this: decreasing here, A prime less than 0, constant here, A prime is equal to 0, increasing here, A prime greater than 0. So, decreasing, constant, increasing absolute risk aversion would have these implications. Main thing is mark what is written in the second column, which is the definitions. Now, we will come to the fourth property, which is basically relative risk aversion property, and it is concept relative sense. That was the absolute sense, this is the relative sense. The formula is given by R w is now. So, we already had u prime is greater than 0, true, minus sign is also there also in A w, here also it is there, W is positive, remember that, wealth. And if you pay attention here, u double prime can be greater than 0, u double prime can be equal to 0, and u double prime can be less than 0. So, based on that you can find out how R w, which is relative risk aversion property, would behave and how it would look like. So, just remember, with respect to A and R, only the factor W has been multiplied in there in case of R. Other concepts remain the same. The numerator is u double prime, denominator is u prime, there is a minus sign, everything. Now, let us consider the relative risk aversion property in its more detailed sense, in the same way as we did for the absolute risk aversion property. So, whatever I am discussing, we will do that in examples. So, if I consider the decreasing relative risk in the relative sense, that was in the absolute sense, then obviously r prime as given here is less than 0. If I consider in the constant sense relative risk aversion property, then r prime is equal to 0, and in the last case if I consider in the increasing sense relative risk aversion property, then r prime is greater than 0. So, there those were with respect to absolute sense, now they are in the relative sense. What do they mean? Again, in the sense when you have decreasing relative risk aversion property, which means r prime is less than 0, then as wealth increases, the percentage held in risk asset increases. That was in the quantum sense, absolute sense, here percentage wise. Similarly, if I have the idea of constant relative risk aversion, r prime is equal to 0, then as wealth increases, increase is there in all these two definitions of A and R. But in one case you will consider the increase, decrease and constant being with respect to in the absolute sense, here in R, which is relative case, it is in the percentage sense. So, continuing the second point. So, as well the decrease increases, percentage held in risk asset remains the same, and finally, as for the increasing relative risk aversion property, which is r prime is greater than 0, as wealth increases, percentage held in risk assets decreases. So, this was basically true. So, we will consider very simply the ideas of sum utility functions. Details I will continue in the next class. Some utility functions which are important is basically the quadratic utility function. So, generally we will consider the quadratic utility function. So, of the form, let me use a different color. Actually, it is of the form A, if this quadratic equation we know a x square plus b x plus c. So, this is basically the quadratic form, and you have the quadratic form as given. So, constant term can be there, need not be there, but in general it is given. So, you will basically have w minus half of c w square is a quadratic, and remember c is a positive constant, we will see that it will come out to be true. In the exponential sense, it is basically an exponential function of the form shown here, minus e to the power minus a w, a is again a positive constant. So, it will give you the exponential utility function. And if you have the power utility function, I will use the red. So, it is c w gamma. So, obviously, c and gamma values as they are given, both are less than 1. And in many of the cases, very simple examples, the utility functions can also be denoted by c w to the power c. So, there is the same parameter. So, the power utility function and this the value of gamma will dictate how the power utility function will look like, because c is a constant, it can be multiplied. And the last one is basically the logarithmic utility function of ln of w, which will be log. And remember, the properties of which we will discuss, if you remember the property of non-satiation, property of risk averse, risk neutral, risk loving, those property 1, property 2, and corresponding also the concept of a prime, r prime, which is absolute risk aversion and its derivative, relative risk aversion and its derivative. All these things would be considered for all these 4 different utility functions and some other cases also, and there you can find out what would be basically the corresponding values of the constant. So, for the quadratic equations we are more interested to find out value of c, then for exponential values of a power utility function value of c and gamma, and logarithmic considering there is no parameter, we will be interested in general characteristics. So, what is important for all these 4 cases is, I am just writing property 1 is important to be checked, property 2 concept of risk, property 3 concept of a prime, and property 4 concept of r prime. So, a prime and r prime are coming out from a and r. With this I will end this 12th lecture and consider in details the concept of these 4 properties, and for this 4 utility functions which are there, and discuss them in further details. Thank you very much and have a nice day.